Looking at problem 1 on the limiting reagent worksheet, we are asked, how many grams of NH3 can be produced from the reaction of 28 grams of N2 with 25 grams of H2? Our first step, as in all stoichiometry problems, is to make sure that the equation is balanced. We see here that they've already balanced this one for us. Now we need to determine how much product, ammonia, or NH3, can be produced from each of the reactants. This involves one calculation for nitrogen and another for hydrogen. Since we see that we are given grams in the question and they ask for grams in the answer, we know that we'll be performing mass-to-mass calculations. And after we find both of our answers, we will compare them. Starting with our 28 grams of nitrogen. As always, with our mass-to-mass calculations in stoichiometry, our first step is to convert to moles. So we'll do this using the molar mass of N2. Looking at the periodic table, we see that the weight of N is 14, and here we have 2 of them. So our total molar mass is going to be 28 grams. We see that our grams will cancel, leaving us with moles of N2. Again, we know our second step is our mole ratio. For this calculation, we will be writing our ratio of nitrogen with ammonia. Now, since we want our answer to be ammonia, we'll put our 2 moles of NH3 on the top of the ratio. And since there's no coefficient here, we know that it's a 1, giving us 1 mole of N2. Our next and final step will be converting these moles of NH3 to grams, since that's what they asked for. So now we'll add up the molar mass of NH3. And since we know that N is 14 and H is 1, and there's 3 H's, our total molar mass is 17 grams. So here we can cancel our moles. And if you perform all of the multiplication on the top and divide by the numbers on the bottom, you'll find a total of 34 grams of NH3, or ammonia. Now we can move on and find how much NH3 would be produced from 25 grams of hydrogen. So, setting up our equation and following the same steps, we will use the molar mass of hydrogen to convert it to grams. Since hydrogen's weight is 1 and there's 2 of them, we know the molar mass is 2 grams. Now we will cancel our grams and move on to step 2, the mole ratio. And since we're using hydrogen in this ratio, we will use H2 and again NH3. Putting NH3 on the top, we have 2 moles and 3 moles of hydrogen. Here we can cancel our moles of H2. And we see that our last step is to convert the NH3 to grams. So I'll put our 1 mole of NH3 on the bottom. And we found in the first problem that our molar mass is 17 grams. So we can cancel our moles, perform our multiplication of the top numbers and dividing by the bottom numbers. We will find 141.7 grams of NH3 could be produced from 25 grams of hydrogen. Now we can compare answers. we see that with hydrogen, or H2, we can make about 142 grams of ammonia, NH3. And with 28 grams of nitrogen, or N2, we could make 34 grams of NH3. So, if we were to mix the two together in the lab, we know, since this is the smaller number, that once 34 grams of ammonia have been produced from our reaction, we're going to run out of nitrogen, which is going to stop the reaction. This tells us that nitrogen, or N2, must be the limiting reactant, or reagent, whichever way you want to say it. Because when it runs out, the reaction will stop. Therefore, we also know that hydrogen must be our excess reactant because it's going to be left over once we reach 34 grams of ammonia. We're going to calculate how much hydrogen is left over in this reaction in problem 2. But looking at this, we can know that what we call this 34 grams is our theoretical yield, which means that, in theory, the total amount of product you could make in the lab using 28 grams of nitrogen and 25 grams of hydrogen is 34 grams of ammonia.